I'm really excited today to have Aaron Prather and Zac Dydek joining me to talk a little bit about the MassRobotics Interoperability Standard. What is it? Why do we care? Does it matter? So let's get right to that. Would you please introduce yourselves? Tell us a little bit about your background and what you're
Well,
up to these days.
thanks, Daniel. My name is Aaron Prather. I'm the Senior Advisor for the Technology. Oops. As we integrate new robotics into our systems, interoperability is really critical, or we're just not going to be able to do it because we have numerous use cases across our network, and sometimes those use cases are happening in the same facility. So if we assign one robot to one use case and another robot to another use case, they might be fine doing those use cases by themselves, but if they're going to do them in the same facility, in the same shared space, we need them to be able to talk to each other.
Mm-hmm. Awesome.
And
Zac?
I'm Zac. Yeah, I'm Zac Dydek. I'm the CTO at Beckner Robotics, roboticist, and been building things and making things work for several decades now. In particular, my main job is to make the robot smart. I've also been closely involved with the AMR interoperability standard that MassRobotics is working on, helping with the technical side of, making sure not only the individual robots can be smart, but that they can talk to each other and, as a whole, be smarter together.
Is your drone broken there behind you?
It won't fly off in the middle of this. Don't worry.
All right. Well, so welcome to both of you. We're first of all, very grateful for the effort that you've put in and that you're willing to share with us today. So, Aaron, I want to jump back in a little bit into what you were talking about at the beginning. I mean, why even bother? Why is this something that needs to be addressed in the robotics industry?
Well, for the robotics industry really to succeed going forward in its mission of just growth and advancing these technologies, they need to be having end users really use their product. But as an end user, for me to use your product, I need to be able to use it in numerous applications and across numerous parts of my network. So if we don't have the technology to a point where I can fully utilize it to its full potential across my network, no one's going to get anywhere in this space. Mm-hmm. Not the manufacturers of the robots and not us end users of this technology. So it's really critical that we work together on these kind of projects like interoperability so we can actually grow the industry into what its potential fully is.
Mm-hmm. Yeah, let me poke at that just a little bit. Why wouldn't FedEx just find the right robot company and use that company for everything?
Well, on two folds, and maybe even a third fold on that. First we're a huge enterprise. We touch 99% of the world's economy. So how many robotic firms could actually supply a single company like ourselves and then even take care of their other customers? So there's one potential problem if there's just no one's big enough to actually supply us everything we need. We buy airplanes from different manufacturers. We buy vans from different folks. We buy equipment across the board from different folks because there's just no one big enough. The second part of that is not everyone's going to build the perfect robot that works on all our use cases. Mm-hmm. People are going to build robots that are good at one use case. Some are going to build maybe robots that are good at 2 or 3 use cases, but I have hundreds of use cases out there. So the whole concept is just like how you see numerous of our different cargo vans out there, different styles, different shapes and sizes, we're matching those vans to the right route, what they're moving, all those things. So same principle, we're going to match the right robot to the right use case. Mm-hmm. And then finally, I would state that, do you really want to be beholden to a single supplier? And as a manufacturer, do you want to be just linked to one end user? That's not a great situation for either of us. Mm-hmm. It's best that we all diversify. And so that if as a manufacturer, if you do lose one customer, that's not going to really hurt you that much. It might be painful, but at least you have other customers to deal with. Same thing. I can't expose my business where if one manufacturer has a financial issue and goes out of business, where I'm now in a world of hurt. So we have to diversify on both sides.
Yeah. Yeah. So you make a compelling point there, right? I think that really frames it up well. Okay. So now let's go in and say, well, can't all these different robots from different vendors just coexist without communicating? Why do we need to communicate?
Well, I mean, we could just use a simple case of, I know a lot of folks out there are working on just moving a package or a manufactured piece from point A to point B. A lot of great folks out there working on that problem. I have numerous solutions of vendors I could pick a robot from. But are they building my mopping robots? Are they building my security robots? Those robots are going to be moving through that same shared space, and what happens when they come across each other. So they're doing two completely different use cases, but they're sharing the same space. So I need them to talk to each other because it's mutually beneficial. We don't want them running into each other. We don't want them messing up each other and harming their own productivity. And as an end user, I don't want to have to deal with a face-off between two robots that can't talk to each other. That slows down my productivity on the human side. So it's very advantageous for folks to build in systems that allow robot manufacturers to talk to each other, just to say, I'm here, I'm going here. Let's make sure we do this correctly as we pass.
All right, so a question then. Aren't we afraid if we allow the robots to talk to each other that they will rise up against us? Is that a concern?
I see where you're going with that.
What do you mean when you say talk to each other, right?
Well, this is where I'm going to let Zac answer that question.
Well, Zac, is that a concern? Yeah. How would robots even talk to each other, and what if they're feeling oppressed? Is that risky?
Yeah, in all of our code, we explicitly set is Skynet to false right at the top. So it's just it's out there. It won't happen. No, the talking to each other piece, gives us a good segue into what the interoperability standard is and what it really does. It doesn't cover everything that robots might want to talk about. We've just focused on a very narrow set of things that we think will provide a lot of value, but also be very easy for different robotics vendors to be able to implement. So things like where you are, where the robot is, where the robot's going. Very simple and very quick to implement. I can show you some of that if you want. Yeah.
No, I'd love to see some stuff.
Let me just share my screen.
While he's bringing that up, Aaron, when will FEDEX get the last 1%?
Oh, it's just down to 3 countries, and I bet many of the folks listening in on us right now probably could figure out who those 3 countries are that don't like to play nicely with the rest of the world. Mm-hmm. So when they're ready to play nicely with the rest of the world, we'll get that last 1%.
Yep. I'm expecting FEDEX to be touching 100% sometime in the not too distant future.
That's our hope too.
Can you see my screen now?
Yes.
Yeah. Okay,
great. This is our GitHub. This is public GitHub repository. Anyone can go to it. MassRobotics AMR interop standard. And in here, we just have a little bit of detail about what the standard is, also what it isn't, which is equally important, and links to more information. We also have some examples of implementations that we've done that people can just take and play with on their own. And also a PDF document is in here as well, which goes into a lot of detail about what exactly is in the standard and definitions and all. We're not going to go into that level of detail right now, But I will show you this little application that is in the GitHub as there's a sender and a receiver. So you can download these and play with them on your own computer or robot. There's a little web-based validator that will sit there and listen for messages that support the standard. And when your message comes into this validator, it'll tell you, yes, it's a valid image. You did it correctly. You implemented the standard correctly. It's also got a little test message functionality. If you click that, it'll just send a test message that's valid. So this is an example of a very basic status message that a robot might send, just saying that it's navigating and here's where it is. That's a tool that's there just so you can see how easy it is to implement this standard with the robot. It takes just a couple minutes to get this up and running.
So Zac, leave this up for 1 second. Yep, there you go. And I want you to first define we for me. You said we earlier. Who is we? And then could you just do UUID, timestamp, operational state, location, and planner datum, and tell us what each of those are?
Talk about what they are. Yeah, what's really going on here. So when I said we, I was probably referring to MassRobotics and the working group that was building this standard. It was a group of robotics vendors, 6, 7, 8 of us, and also customers like FEDEX, end users, and other kind of industry folks who have dealt with these challenges before of the robots not being able to talk to each other, and had those frustrations and wanted to find a way to get together and just come up with something to alleviate some of that. And to go to your other question about what's in these messages, you can read about it in that PDF and get more detail, but basically the skeleton here of a very simple status message. This is, I think, the minimum that you can send. There's some optional things that you can add to it, but you need to identify your robot somehow. So this is just a string that identifies uniquely, this is the robot that's sending the message, the time that it sent the message, what the robot's doing, the operational state. This robot's navigating, so it's actively making progress to some new location.
Or it could be what?
If it's not navigating, it could be charging, it could be idle, it could be waiting for something else. There's a list of all the possible values for that in the standard as well, for some guidance. And then there's a location, which is an XY position and an angle. And these are in a reference frame, and that's what this planar datum refers to. It refers to an identified reference frame with this ID. And this is kind of one of the trickier parts of the standard. Again, not to go into too much detail, but every robotics vendor has their own understanding of the world, their own maps, maybe, and to be able to make everyone be able to talk, in a common frame of reference with everyone else, we had to do some thinking about how we would reference those different maps to one another. And the approach we came up with is pretty simple, and it's detailed in the standard document. But you have to, when you give a position, you have to give a reference to, what does that location refer to? What's the origin that you're comparing your location against? And that's what this planar datum does. So,
okay, and does that work indoors and outdoors?
Yep, indoors and outdoors. In the end, everything gets converted to a GPS equivalent signal. So if you're outdoors, you're giving your GPS position, and that comes in and gets converted into something that could be referenced with everything else. If you're indoors, might be multiple floors, different levels. Those all get converted into kind of GPS equivalent coordinates.
Cool. Well, I certainly understand it much better than I did before this call. Other highlights that you want to point out?
No, I would just say take a look at this GitHub if you're interested in what's in the standard. It's it's detailed out here. We released our version 1.0 a couple weeks back, and excited to have people use it and give feedback. Any questions or comments that people have, would love to hear more about those.
Well, so how do they do that? How would people get involved or provide feedback or those type of things?
Yeah, great question. At the bottom of the GitHub, there's a link to MassRobotics, which you can follow. And in here, there's a form you can fill out. So that's a great way to get your feedback in front of the right people to be able to see it and respond to it.
So once a company has implemented the interoperability standard, I am told that they then have the opportunity to display the AMR Interop badge. So Aaron,
Yeah.
will FedEx be looking for that badge in their future purchasing decisions from robotics vendors?
I really think it will. I think it'll be very similar to how we look for like a UL or CE stamp, those kind of things. And because it will tell us this robot, this piece of automation meets a certain standard that we use within our operations. So yes, I really hope that we see this is the way we're going to go, and other end users will be able to look for that stamp and saying, we're good to go. Let's move along on this. And it'll be just one of those check boxes eventually.
Yeah. Well, and I think the good news is it sounds like it's really easy to implement it. So that shouldn't be an obstacle for anyone to do business with FedEx.
Absolutely.
Great. Well, any final thoughts before we wrap up?
I would just like to thank the entire team that worked at MassRobotics on this, folks like you and Zachary on this. I think this is just the first step, but it's a great first step. And it just shows that the industry can work together to solve these issues. I think we're taking some very good preemptive steps. We've seen where other pieces of technology didn't really address some of these early issues early on, and then had to go back and sort of fix them, and that slowed the industry down. So I'm very proud of the industry of coming together on this and working on this, because us end users are going to really appreciate it further down the road, and we'll be able to look back on this and saying that's why we were able to move forward this quickly in deploying robots.
Yeah, well, and I have to give a bunch of kudos to FedEx for helping to lead the charge. And all of the people who have gotten involved. Yes, there were a number of robotics companies, there were a lot of end users, there were component vendors. So yeah, lots of credit goes to lots of people for contributing to this. So great. Well, thank you so much, both of you. I think it was an excellent discussion.
Yeah. Thanks, Daniel.